Hi, I'm Kanoa Nakama, and I'm studying mechanical engineering at Palomar Community College. I'm the mechanical design lead and focus on the positioning and orientation of the thrusters, as well as the power consumption in regard to the electrical design.
I'm Cody Pennefather, studying mechanical engineering at Palomar Community College. I am the second mechanical design lead for this project. My relevance to the propulsion system is that I worked on the IMU and the PID controller for the propulsion system. The propulsion system's purpose is to move the AUV throughout the competition course that optimizes the power consumption and allows our robot to orientate itself in the degrees of freedom necessary to properly navigate through the task that we are planning on attempting.
Our competition strategy is to qualify on-site by having our AUV complete the gate task. We determined the movement for the gate task, and future tasks that we could consider attempting only needed to be linearly on the XYZ axes and rotational on the Z axis. This led us to lay out our thrusters with 4 horizontal thrusters at 45 degrees and 2 vertical thrusters on both sides of the frame. This design proved to be easy to implement as well as proven reliable by past teams and commercial ROVs and AUVs. This played into designing our power supply as well. We decided to limit our thruster current draw to 7 amps compared to the max current draw of the T200 thrusters being used at 23 amps at 16 volts. Probably should specify some of that earlier. Anyways, because our AUV doesn't have to be fast to complete the gate in 15 minutes. With the consideration of the power draw of the thrusters, we chose a relatively smaller battery of 8,500 milliamp hours for a theoretical runtime of 25 to 30 minutes at full thrust. For now, our confidence rating in the gate task is unknown due to not being able to test it with our robot, but we feel that is most likely doable once we do have a working robot.
Our team has not yet manufactured nor tested our AUV. However, we have used a smaller differential drive robot to test our code for degrees of freedom, IMU, PID controller, and OpenCV. We've chosen to utilize our first year to focus on what we were least familiar with, which was our code development for propulsion. We implemented the PID controller movement based on using the complementary filter and common filter for the IMU data. To test the practice bot, we plan to make a mock gate task with the same colorings and scale down the PVC pipe as one used in the competition.